Hello once again, ladies and gents. All right, so I'm continuing from the previous question that I had done with you. All right, so you remember what we had actually found out the concentration of the barium hydroxide, in this case, to be zero point 0.2, right? Now, the next question, they say to us, calculate the concentration of hydronium ions in the final solution. Okay, so what they do is that they take the barium hydroxide and they are going to obviously, put it or mix it together with sulfuric acid, as the question suggests there. All right. And they want to know what is the concentration of the hydronium ion. So, which means they are assuming that sulfuric acid rather will be in excess in that case. All right. Now, here's what we're going to do. Right. So, first of all, would it be possible? Remember, they said 25 cubic centimeters of barium hydroxide, okay, was used. So, in this case, what I can do is I can calculate the number of moles of barium hydroxide, okay. So, I am going to calculate the number of moles. I think this is 7.3.2.2 rather. So I'm going to calculate the number of moles of barium hydroxide. Okay, that's concentration times volume. Remember, our concentration was 0.2. And the volume, remember, it's the one that's given. They said 25 cubic centimeters, right? So in this case, we're going to divide that by 1,000. So that will give me 0.025. All right, so let's calculate that. So that's 0.2 times 0.025. And I get 0.005 moles. That's going to be for barium hydroxide, right? But now, what I'm going to do is I am now going to also calculate the number of moles of sulfuric acid, right? They had told me that I've got the concentration rather is 0.15, and the volume, right? They said 40 cubic centimeters of aqueous solution of sulfuric acid. So now I know the volume and the concentration, right? So number of moles of sulfuric acid. Okay, so that's going to be concentration times volume, right? My concentration is 0.15 and the volume is 40, so that's 0.04. Remember, you say 40 divided by 1,000. Okay, so I've got 0.15. Oh gosh, 0.15 times 0.04, and I've got 0.006 moles of sulfuric acid. Now, of course, they actually, assumed, or rather, from the question, it's assumed that we're going to have hydronium ions that are in excess. So, what is that telling you? It's telling you that we're going to have, it means that sulfuric acid is actually in excess than barium hydroxide. Now, let's find out how much sulfuric acid will be in excess, right? So in this case, remember, in our reaction, for every 1 mole of barium hydroxide, okay, right, so you go back to the reaction, it says for every 1 there's 1, right? So for every 1 mole of sulfuric acid, you've got 1 mole of barium hydroxide. So that means if you use 0.05 of barium hydroxide, then you should be able to get 0.05 of sulfuric acid, or use rather 0.05 of sulfuric acid. So for every 1 there's 1 of sulfuric acid. right? So if I've got 0.005 of that, how much sulfuric acid will I use, right? So the number of moles of HCl that I use in this case. So I will cross multiply. So number of moles of sulfuric acid used will be equal to 0.005 moles, right, from cross multiplication, right? But now, what are these? These are the initial number of moles. So this is the amount of acid that I had, right, that I started with. But I find out that I use this amount. So the number of moles of acid that is in excess will be the number of moles initial, okay, minus the number of moles that are used, okay. So I've got 0.006 minus 0.005, and in this case that gives me 0.001 moles, okay. So these are the moles in excess. However, we were looking for the concentration, all right, of our hydronium ions. You remember that, yeah? So we're looking for the concentration of hydronium ions, but so we need to find out first, how does sulfuric acid ionize, right? So in this case, sulfuric acid actually is a diprotic acid, so it will give us two of those hydronium ions, right? So for every 1 mole of sulfuric acid, rather, you get 2 moles of hydronium ions. So therefore, the number of moles of H3O plus, don't be alarmed when I say H3O plus. Remember, H plus and H3O plus are exactly the same thing, right? In this case will be twice the amount that I have in excess. So that will be 0.002 moles. So now I can find out the concentration of my hydronium ions. Okay. So that will be number of moles divided by the volume. So that will be 0.002 divided by, now remember, in the volume, right? Remember that we added the amount of 25 cubic centimeters to 40 cubic centimeters of the acid, right? So what will be the total volume? That should be 65 cubic centimeters, right? So that would be 65 divided by 1,000, so that would be 0.065. And ladies and gents, essentially we've almost come to the end, okay, of this question. So that's divided by 0.065, and I get 0.03 moles per cubic decimeters. Okay, right. So please have a look at this question once again, and you'll see that when it comes to this acids and bases, if you can understand this portion, you should be okay. All right. Otherwise, from me for now, I'll see you guys again next time. I hope you really, really found this helpful. All right. Sharp, sharp.